Guys, welcome back to my channel, Meson African Motives, still working on mathematics entry. So in this platform, we have got the paper that we're going to work on, which was actually written November 2022, which is an X paper. So just we'll quickly rush through the questions so that we see what we're supposed to do. Remember your instructions, information, read everything, especially on the degree of accuracy, round off to 3 decimal places whenever there is a need for that. And everything, make sure that you understand the instructions and the information. So not wasting much time, let us quickly rush through the first question, which is our question number 1. We had the part which was to factorize the following polynomial fully and simplify the answer completely, which means we are supposed to make sure that we have factorized fully and simplified everything completely so that we can obtain the marks that are given there. All right, so not wasting much time, let's see the first part, which is 1.11. I'm just going to write it aside so that we can clearly see what was supposed to be done on this one. So we're given minus x cubed minus 4y squared plus x squared y plus 4xy. So that was the person. And we are asked to factorize. So remember, guys, whenever you are factorizing, you are supposed to make sure that you work with the terms that are there. In this case, we've got 4 terms. So that means we're supposed to use by grouping. But for us to apply by grouping, make sure that the terms that we have can be factorized. If we are to cross-check the first 2 terms, we do not have anything that is common. Yes, on these last 2, we have got y, which is common, x is common, but the first 2 here, we do not have anything. So there we can be able to rearrange. All right, so in this case, I'm just going to start with, it depends with how you're going to rearrange it, but I'm going to start with the positive x squared y here. So more followed by x cubed, there is x here, there's also x, I'm gonna have minus x cubed. Okay, then if we are to see that here we want to have the same expression just like what we had on this one. So we are going to have the last expressions in this case, which is plus 4xy and minus 4y squared. So I'm going to have plus 4xy minus 4y squared. So the order there, like I'm saying, it does not matter how you are writing it, but since we've got x here, we can also rearrange. Okay, we can just rearrange maybe in this manner so that you can understand me much better. X cubed y, x squared y minus x cubed minus 4y squared plus 4xy, like that. Still, it's one and the same thing. You can write it this way or you can write it this way. There's no matter there. All right, now grouping into 2, let's see what is common. For the first 2 terms, we've got x squared, which is common, so I can factor out x squared. I'm going to remain with y minus x cubed divided by x squared, that's x. So take note, we are supposed to obtain y minus x from these last 2 terms that we have. So what are we supposed to factor out so that we can have a positive y squared? That's definitely negative. 4 is common and also y is common. So if we factor out negative 4, this can be a positive. So we're going to have positive y. 4xy divided by minus 4y, positive and negative, that's a negative y, and y can cancel, we remain with x. So as you can see that the 2 brackets are just the same, so we can factor out the common bracket from these ones. So we are going to have y minus x. We are remaining with x squared minus 4y. So we're going to remain with x squared minus 4y, of which in this case, there is nothing that we can do further because we do not have any common term. We do not have any difference of 2 squares. So that was the answer that we could have determined, that we could have found from that one. Let's see the other part of the question. So 1.12, we are now given again to factorize. We've got b squared minus 4bd plus 4d squared minus, there is a bracket of 2b plus d. So let's see what we can do. This one, I'm just going to rewrite just like what we did from the previous question. We've got 1.12. We had a b squared minus 4bd plus 4d squared. But if we are to cross-check here, we're given a bracket that we're supposed to expand. That is 2b plus d squared. So there we're supposed to expand this bracket. It's either we're going to have two brackets that you're going to expand of 2b plus d. We can even expand 2b plus d into 2b plus d. So if you have to simplify 2b and 2b, that is 4b squared, 2b and d, that's 2bd, d and 2b, that's again 2bd. Then we've got d and d, which is going to give us d squared. So we are going to be having 4b squared, 2 plus 2, that is 4bd plus d squared. So this is the part that we're going to have after expanding that bracket. So this is going to be 4b squared plus 4bd plus d squared, like that. Okay, so that means we can be able to factorize there after. Let's expand the bracket, both this. The negative here is supposed to expand each and everything. So we're going to have b squared minus 4bd plus 4d squared minus 4b squared. Then we've got negative and negative here. Negative and positive, that's a negative. So it's going to be negative 4bd. Negative and positive, that's a negative. So you're going to have negative d squared. So that means we can be able to collect like terms. If we have got like terms, let's see what do we have. The b squared, just we've got b squared here, and also we've got b squared there. So it's 1b squared minus 4b squared. So 1 minus 4, that's minus 3 b squared. Then we move on to BD. We've got BD here. We've got BD here. This is negative 4, negative 4. So negative 4 is going to give us negative 8. So we're going to have negative 8 BD. And now we move on to the other part of d squared. We've got d squared here, we've got d squared here. So this is same as minus 1d squared. So we've got 4 minus 1, which is 3. So we've got plus 3d squared. Okay, so that's what we had. For us to factorize here, we can actually factor out the negative so that the b squared can be a positive. This term can be a positive. So you can factor out negative. That means we are going to remain with negative by negative, going to be positive 3b squared, negative, negative, that's positive 8bd. Then we've got negative and positive, which is negative 3d squared. So this is what you're going to have at the end. But it's not yet done, because we have got 3 terms, which is 1, 2, 3. So this part is different from the previous part. We've got 4 terms where we could factor out by grouping. This time, remember the longer way that you're supposed to have to multiply the first term to the last term. So that was the only way, which is going to give us negative 9b squared d squared. What are the factors that we are going to have for negative 9b squared d squared? But if we add them, they must give us the middle term, which is 8 bd. So in this case, we have got 9 and negative 1, 9bd and negative bd. If we multiply these two, we get negative 9 b squared d squared. If we add, we get positive 8. So these are the factors that you're going to substitute into the middle term in place of 8bd. So you're going to have negative 3b squared. Then we replace with these two terms. That is 9bd minus bd minus 3b squared, like that. Okay. So from this stage, we can now apply grouping into 2. Grouping into 2, we can factor out what is common. In this case, 3b is common, so you can factor out 3b. 3b squared and 3b remain with b plus 9 divided by 3. That's 3b and b cancels. You remain with b. On the last 2 terms, we've got a negative, which is common, and also d is common. So if we factor out negative d, this is going to be negative by negative, that's positive b. Negative and negative, that's positive 3d. So as you can see that the brackets are the same. So we can factor out one of these brackets. We can just factor it out. So it's going to be negative b plus 3d in bracket. Then we remain with 3b minus d. So it's going to be 3b minus d, like that. So that is what we're going to have at the end if we are to factorize this properly. that is what we're going to have. So make sure your factorization is done properly. Check your steps. The way that you factorize, make sure that everything is in a proper manner, just like what we had on this part. Okay, let's check the other part. 1.2, we are now asked to solve the equation by completing the square. So remember completing the square method. So we're just going to apply that method to solve this equation. That's 1.2. So we were given the equation x squared minus 4x plus 2 is equal to 0. Remember, by completing the square method, the first thing we can actually transpose the 2 to the other side of the equation so that we can have x squared minus 4x is equal to -2. So what's the next stage? We have to find half the coefficient of x. In this case, the coefficient of x is -4. So half of -4, that's -2. Then we square that half. So after squaring, remember you're supposed to add both sides of the equation. The square that we have obtained, which is going to be x squared minus 4x plus the square that we got, which is -2 squared, which is equal to -2 on the left-hand side, on the right-hand side, plus the square that we obtained of 2. So that is what you're going to have. Then from the left-hand side, we can factorize taking x and -2. We are going to have x minus 2 squared, which is equivalent to this one. We can just apply our calculator. -2 plus 2 squared, that's something like 2. -2 plus -2 squared. That's a 2 there. Okay, so we're going to obtain a 2. So this side is going to be 2. So from there, how do you remove the square? We have to introduce the square root. We've got a square here. So we're going to introduce the square root both sides of the equation. That means x minus 2 is equal to plus or minus square root of 2. Remember that square root of any number is a plus or minus. So transposing the -2 to the right-hand side is going to be a positive. So you're going to have 2 plus or minus the square root of 2. So from there, we can separate. Remember, there's a plus and a minus there. So x can be equal to 2 plus the square root of 2. Or we can have another x, which is equal to 2 minus square root of 2 from the sign plus and minus. So therefore, you can leave your answer like that, or you can simplify from the calculator. We've got 2 plus square root of 2, 2 plus the square root of 2. That's something like 3,414. So we're going to have 3,414. We are not given the degree of accuracy. We're going to leave to 3 decimal place, which is 3,414. Or another x is going to be, we just have to change here to a negative. So this is going to be negative. So we've got negative 0,585, which we round off is going to be 6. So 0,586. So these were the two possible values of x. You can leave your answer in Z form or as a they're like a decimal. It depends with what was best for you. In this case, 1.3, use vector and remainder theorem to factorize hx completely. And of course, 6 marks to factorize that. So remember, whenever you are dealing with factor and remainder theorem, to factorize is all about finding the factors of the last term. So this was 1.3. Okay, so let's just write it here. 1.3, we've got h of x, which was equivalent to 3x squared minus 9x, 3x cubed, actually minus 9x squared plus 12. So we can figure out what is common in this case, which is 3, but that one we can even do it later on. Okay, so remember that we are supposed to find, according to factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, these values of x. The factors of 12 that we are actually working with. So we just have to try all of these factors. One that is going to, when you substitute the value here, we are supposed to obtain a 0. So without wasting much time, I'm just going to try 2. Let's see if we are to substitute 2 in this case. Here we've got 3 into 2 cubed minus 9 into 2 squared plus 12. Okay. So by substituting 2, we've got 3 into 2 cubed. That's a cubed here. All right, we've got cubed. Minus 9x squared, which is 2 squared. That's 2 squared is 4 actually. Okay, anyways, plus 12. we are going to obtain a 0. Okay, so that means in this case, h of 2 is going to give us a 0. Remember, for any number that can give us a 0, we know that it follows that x minus 2 is a factor. That is what it means from that part. If it was 3, therefore x minus 3. If it was minus 2, then it means x plus 2 is a factor. You just introduce a negative. So we already have a factor. So it depends with the method that you have used. Sometimes you might not obtain exactly the way that I am having here. We can try some numbers in this case, like -1. Let's see, maybe someone tried -1. Let's see. 3 into -1 cubed minus 9 into -1 squared plus 12. Let's see what we're going to have. So you try anything that can give you a 0. That one is the one that you're going to work with. So these ones might differ, but the answers are going to be the same. So that one, do not worry, the answers will be the same. So we've got -1 here. This is -1. All right, that's a 0 again. So as you can see, h of -1 is giving us a 0. So therefore, it follows that x plus 1 is a factor. That is what it means. So it depends as which factor you're going to use. If you have got x plus 1, you're going to divide by x plus 1. If you have got x minus 2, you're going to divide by x minus 2. But the resultant is going to be the same. But as for me, I have 2 as my factor. So this is one that I'm going to use. If you had x plus 1, let's see the final answers if they are the same. Okay, so using x minus 2 as my factor, I'm going to divide x minus 2 into the whole expression, which is this part of hx. So we've got 3 x cubed minus 9x squared plus 12. Remember, guys, your long division. If you're applying long division, we're going to divide first term by the first term. So it's 3x cubed divided by x, which is going to give us 3x squared. We multiply back here, 3x squared is going to multiply everything, that's x plus 2. So it's 3x squared times x, which is 3x cubed, 3x squared minus 2, which is going to be minus 6x squared. We are done on this part, then we subtract. Okay, so we're going to subtract. Subtracting here is 3x cubed, that's a 0. Minus 9, minus 6. You can even use your calculator, guys, if you are not sure about it. Minus 9, minus 6, like that, you can get an answer, which is minus 3. So we're going to have minus 3x squared. Then we drop down the 12, which is remaining. So it's just a plus 12, that one. Okay, next stage, we divide again. X is being divided here. So it's minus 3x squared divided by x, which is going to give us negative 3x, because we've got x squared there. It multiplies back just like what we had from the previous part. It multiplies everything. So it's minus 3x by x, which is minus 3x squared. Minus 3x by 2, which is a positive 6x. So we can actually subtract. Okay, so this was a plus 12. So we can subtract here. Just have your brackets. Let's see what we are going to have if we are to subtract. As you can see, the first term, these two terms are the same, so that one is going to be a 0 there. We do not have a term with x, so it means we have got something like 0x. That is what it means. So it's going to be 0 minus 6. 0 minus 6, that's minus 6x. The 12 is just going to remain as it is. Okay, so that is what we have after subtracting. We divide again. First term to the first term, so it's minus 6x by x, which is minus 6. Minus 6 multiplies back everything in that part. That is going to be negative 6 by x, which is negative 6x. Negative 6 by negative 2, that's a plus 12. So as you can see, guys, these terms are the same. So if we are to subtract, these terms are the same. That's a 0, 0 there. All right, so after dividing, this is what we are obtaining. We obtained the first factor, so this is what we are going to have on our h of x. Our h of x is equal to x minus 2. That was our first factor, x minus 2. Now we obtained a quadratic expression, this one on top. So this is the other one that we're going to write, which is 3x squared minus 3x minus 6. So that's what we have. We are not yet done because this is a quadratic expression. We are supposed to factorize it fully. But we've got 3 is common, so you can factor out the 3 outside. we've got x minus 2. If you factor out 3 here, you're going to remain with x squared. If you factor out 3 here, it's going to be minus x. If you factor out 3 here, we are going to remain with minus 2. It's minus 6 divided by 3, that's minus 2. All right, so let's check. What do we have? Can this term be factorized? X squared minus x minus 2. So this is same as 1x squared. So remember, if it is like that, we just have to focus with the last term, which is the constant minus 2. Do we have factors of minus 2 that we can add and we can obtain negative 1, which is the middle term here? Yes, we've got minus 2 and 1. If we multiply, we get minus 2. If we add, we get negative 1. So these are the ones that we are going to write. So answer is going to be 3 into x minus 2. We've got factors minus 2 and 1. So one bracket is going to be x minus 2. Another bracket is going to be x plus 1. Okay, so that is what we had as the last part after factorizing completely the whole expression that we're given. So guys, as you can see, if you are dealing with factor, and remember that it must be that you follow the stages properly. Make sure that you follow the given stages properly. So that was 1.3 and for 6 marks for that. The other part, which is on 1.4, was for us to simplify the following algebraic expression. Okay, so I'm just going to write down our algebraic expression on 1.4. We've got x plus 3 over, definitely you're supposed to factorize first here. So the advantage was that the coefficient of x squared is 1, so you just have to focus with 12. What are the factors of 12? If we add, we get negative 7. So that's negative 4 and negative 3. If we multiply this, we get positive 12. If we add, we get negative 7. So it was going to be x minus 4, x minus 3, okay? Minus, on top, we've got x minus 3 over x squared minus 9. That's a difference of 2 squares, x squared minus 3 squared. So we've got x and 3. So we know that one bracket is going to add, another one is going to subtract, x plus 3, x minus 3. So from these two brackets, we can actually cross-check. These two can cancel, x minus 3, x minus 3. So you can cancel some of these things, guys. Don't keep on like these fractions. You can actually cancel them. So that means we were going to remain with x plus 3 over x minus 4 into x minus 3 minus 1 over x plus 3. So that is what you're going to have at the end. As we know that when we are subtracting or when we are adding, we have to find the LCD or the LCM of the given denominators. That is, we've got x minus 4, we've got x minus 3, we've got x plus 3. So let's divide our LCD divided by the denominators x minus 4, x minus 3 will cancel, you remain with x plus 3. So we've got x plus 3 on top into this part of x plus 3 that is remaining, minus, we do the same here, we've got negative x plus 3 and x plus 3 will cancel, we remain with x minus 4, x minus 3. So that is what we're going to have at the end. So without wasting much time here, we can expand the given brackets, because here we've got brackets that we're supposed to expand. So let's expand and see what you're going to have. That's x and x there, which is going to give us x squared. We've got x and 3, which is going to be positive 3x. We have got 3 and x. This one is going to give us plus 3x again. We have got 3 and 3 times 3, that is 9. So this was going to give us 9. Okay, so on this one, we had two options, either to expand first these two brackets, then whatever that we get, we multiply by negative, or we can just multiply by negative one bracket. Negative times x, that's negative x. Negative times negative 4, that's plus 4, like that. So now the negative is already used. We can now expand negative x by x, which is negative x squared. Negative x by negative 3, that is positive 3x. 4 and x, that is positive 4x. 4 and minus 3, that's negative 12. Everything over the denominators, x minus 4, x minus 3, x plus 3. Okay, then from there, collect like terms. If they are like terms, we can simplify further. Like terms, do you have anything that has got x squared minus x squared? That one can cancel. we've got 3x plus 3x, 3x again, 4x. So we're going to add 3 plus 3 plus 3 plus 4. So that is what you're going to have. So we've got 3 plus 3. That was 3 plus 3, 3 plus 3 plus 3 again, plus 4, which is going to give us 13. So we are going to have here 13x. Then we move on to the constants. We've got 9 minus 12. 9 minus 12, that's minus 3 over everything that is x minus 4, x minus 3, x plus 3. So that is what you're going to have at the end. From that given expression, that is what you're going to have at the end. So it is very, very important that whenever you are adding or subtracting, you follow the procedures, you keep the LCD up to the final answer, just like what we had up to the final answer. So that is it for you. Okay, 5 marks. And at the end, you've got 22 marks on question number 1. So which means if you can totalize this, we just need about 18 marks for you to have 40 marks. So you see, it's very, very easier to pass maths and pre. Anyways, let's see the 2.1. We're asked to solve the equation. Solve for x, the following equation. So that's an equation in terms of x. I hope it's going to be enough for me to write it here. All right, that's 2.1. In this case, we had e to the exponent of x. Here we've got e to the exponent of minus x squared plus 6. So there were so many ways, so many ways for you to rearrange everything so that you end up with an equation. But at the end, we are going to obtain the same answer. That was it. Okay, so what you can do, you can transpose. First, we've got e to the exponent. Let me just reduce a little bit here. All right, so something like this. We had e to the exponent of x over e to the exponent of minus x squared plus 6 equal to, we can transpose the minus here to the right-hand side so that it can be positive, e to the exponent of 2x. Okay. From the left-hand side, we've got e, the denominators are the same. Remember, if you are dividing the denominators which are the same, the bases, sorry, which are the same, you subtract the exponents. So this was going to be e to the exponent of x minus x squared plus 6, which is equal to e to the exponent of 2x. Okay, so if we are to subtract, it's going to be e to the exponent of, that's a negative and a negative, which is a plus. So it was going to be x plus x squared, negative and positive, that's minus 6, which is equal to e to the exponent of 2x. Remember, from our laws, guys, x to the exponent of a, if it is equal to x to the exponent of b, it simply means that a is equal to b. So the bases and the bases are the same. Therefore, you can equate, that is x plus x squared minus 6 to 2x. We can equate that one. So we are now left with a normal equation. There is no e, it's just a normal equation that you are used to. So that means we can group like terms, x squared, take the minus, the 2x on the left-hand side is going to be minus. So this is same as 1x minus 2x, which is minus x minus 6 is equal to 0. So what do we have? That's a quadratic equation. How do you solve a quadratic equation? It depends. You're going to use the quadratic formula, factorization. I don't know which method was best for you, but factorization was the easiest, since we just need 2 brackets that we are going to equate to 0. And from these brackets, because the coefficient of x squared is 1. So what are the factors of negative 6? And these factors, if we add, we are supposed to obtain minus 1. So we've got minus 3 and 2. If you multiply these two, you get negative 6. If we add, we get negative 1. So these are the factors that we are going to have. That's minus 3 and 2. So we've got x minus 3, x plus 2 is equal to 0. So definitely it means x is going to be minus 3. To the other side is going to be positive 3, or x is going to be plus 2. To the other side is going to be a minus 2. So x was going to be 3 or minus 2. So that's what we had from the values of x, just solving. That was just a normal solving, but we're supposed to be very, very clear on the exponents and application of the laws. Okay, but that was it. Let's see the other part, which is 2.2. If 6 to the exponent of 2x is equal to 4 to the exponent of x plus 2, prove that x is equal to log 16 base 9. This was one of the hardest questions. But I just hope we understood what was happening here. Okay, we all know that once we are given this, we can't make 6 and 4 to be the same base. We're supposed to introduce logarithms. So if we introduce logarithms, we're supposed to have log 6 to the exponent of 2x, which is equal to log 4 to the exponent of x plus 2. We know that after the simplification or the introduction of log, we're supposed to drop the exponent from the laws of our logarithms. So it's going to be 2x log 6, which is equal to x plus 2 log of 4. So that's it. Expand by log 2x log 6 is equal to, we've got x times log 4, that's x log 4. 2 times log 4, that's 2 log 4. So from this part, if we are to cross-check, our answer is in terms of log. So you're not supposed to simplify log 6. You're supposed to leave it as it is. So, but we can collect terms with x, collect terms with x to one side of the equation. We are going to have 2x log 6. That's, if we are to transpose this, is going to be negative x. So we've got negative x log 4, which is equal to 2 log 4. Okay, x is common from these two, so we can factor out that x here. So if I'm to factor out x here, I'm going to have 2 log of 6 minus log of 4 equal to 2 log of 4. Okay, in a normal way, we know that we're supposed to divide here, but it doesn't make sense, whatever that you're going to have. Let's just try and simplify and see what you're going to have in this case. Okay, I want us to take a closer look what is happening on this bracket here, this bracket. We have got 2 log of 6 minus log of 4. Okay, so let's apply our logarithms. We know that the base, this number is actually, we are supposed to have a single log. Let's try to have a single log. So what can we do in this case from this single log? We can raise the 2 to be the exponent. Remember, p log of m is equivalent to log m to the exponent of p. So that means this was actually going to give us log 6 squared minus log 4. Okay, 6 squared, that is 36. So we've got log 36 minus log of 4, of which we know that logarithm of a minus the logarithm of b is the same as the logarithm of a over b. So if we are subtracting logarithm, the bases are the same, we can actually divide the numbers. That's 36 divided by 4, which is going to give us log 9. So in this case, this whole part is going to give us log 9. So it's going to be x log 9 is equal to, we do the same on log 2 log 4, just like what we did on 2 log 6. We have to raise this to be an exponent 6 squared. So this one is going to be 4 squared, and 4 squared, that is 16. So we're going to have log of 16. Okay. Since we want to calculate x, what are you supposed to do? You're supposed to divide by log 9. We do not need this one, log 9 both sides. So actually this can cancel out. So x is equivalent to the logarithm of 16 over the logarithm of 9, which is equal to what? Remember from your laws of logarithm, the logarithm of a over the logarithm of b is the same as log a in base b. So that means log 16 divided by log 9 is same as log 16 in base of 9. So that is our x, which is actually proven. This is what the person was asking you to prove, that x is equivalent to log 16 in base of 9. So guys, this was actually one of the questions, but I think it was supposed to have a little more marks than the ones that were than the one which is 4 marks. They were supposed to add some marks there. Okay, anyways, that was it. Let's see the other part of the question, which is 2.3. We are now asked to simplify the following expression. We had so many ways again to simplify this type of expressions. In this case, I want you to see there's a relationship that we have between a minus b, this part. So don't simplify that part. But remember from your laws of exponent, if you're given the 8th root, or maybe let's just say the base root of x to the exponent of a, it means it was x to the exponent of a over b. So that's what is happening. We've got square root here. So it simply means this was supposed to be written as a minus b to the exponent of 3 over 2. Okay. Here we've got the square root of a minus b, the square root of a minus b. Remember from your laws of sets, square root of a by square root of b is equal to square root of ab. So if we are to multiply here, we've got a minus b, a plus b, we are supposed to obtain, actually we were supposed to obtain the square root of a minus b into a minus b like that, but a plus b, sorry. But remember, a minus b, a plus b is a difference of two squares, which simply means the square root of a squared minus b squared. And the square root means to the exponent of half. So this was going to give us a squared b squared to the exponent of a half. Everything over here, we've got the same thing, 3 over 5. So it's going to be a minus b to the exponent of 3 over, that's 5 over 3, not 3 over 5, 5 over 3. Then we've got already simplified this one, a squared minus b squared to the exponent of a third. Okay, so not wasting much time, we can see that a minus b are the same. We are dividing the bases here, which are the same. So you can simply subtract the exponents. So this was going to give us a minus b to the exponent of 3 over 2. Then we actually subtract 5 over 3. Then we move on to this same thing here. We've got a squared minus b squared to the exponent of a half minus 1 over 3 because we are dividing. Okay, so let's see what you're going to have from our exponents. 3 over 2, that's 3 over 2 from the exponent, minus 5 over 3. Okay, that's going to give us negative 1 over 6. So we've got a minus b to the negative of 1 over 6. A squared minus b squared to the exponent of what? Let's see the answer there. That's a half minus 1 over 3. Minus 1 over 3, which is going to give us 1 over 6. Okay, so from this part, this is the part that we are actually having, the sixth root of this and also the sixth root of that. I want you to see the magic actually that was going to happen here. Let's move stage by stage. I want you to see something. I'm going to put it here. All right. We can actually see that here there is a negative exponent, which we know is 1 over, let me take you back, x to the exponent of minus a is 1 over x to the exponent of a. Okay, so we are supposed to write this as 1 over a minus b to the exponent of 1 over 6. Okay, which is the same as multiply. This is a positive, so it's going to be on top. So it's going to be a squared minus b squared to the exponent of 1 over 6. Okay, but remember what we did before. We said a squared minus b squared was taken from a minus b, a plus b. Remember what we did. So it simply means this part here can actually be written in this manner. We can separate this part into a minus b, a plus b again, but everything to the exponent of 1 over 6 over a minus b to the exponent of 1 over 6, which is in the denominator this. So knowing that this exponent is going to affect everything, this one is going to be affected, also this one is going to be affected by the same exponent. So we're going to have a minus b to the exponent of 1 over 6, a plus b to the exponent of 1 over 6 over a minus b to the exponent of 1 over 6, which can cancel a minus b, they are the same. So at the end, your answer was going to be a plus b to the exponent of 1 over 6, or you can write it as the sixth root of a plus b, like that. That was another option of writing your answer or other way. So that was it, guys, for you to obtain 5 marks and at the end 14 marks. In question 2 was actually having 14 marks at the end if you had to cross-check properly. So these were the stages that you actually needed. As you can see, guys, these are the typical questions that you actually have, and it's actually 14 marks for that. Okay, let's check question number 3 and see what we're actually given. So the first part of question 3, it was actually a word problem that you were given to work from. Word problems, guys, it's a matter of analyzing whatever that you are given so that you can attempt the question the way that you understand. Okay, anyways, we are given that on 3.1. There are 3 friends that we are talking about, which is Vosi, Lovio, and Fusiso. So these 3 friends went to a gamble at a casino. Vosi won half of what Fusiso won. So it's like those problems that we see. I don't know, guys, what I can say about this. typical word problems. Okay, so anyways, what we are going to do, not to waste much time, I hope it's going to be clear here. I'm going to write it on top. Yes, I hope it's going to be clear. Okay, so this is what is happening. I don't want to miss to this problem. Okay. In this case, we've got we'll see love your ends, we'll see. So let's just say we'll see got X rand. Okay. Then Lovia, let's just say she got Y, and we'll see. So let's just say she got Z. Okay. The first thing is that we'll see 1/2 of we'll see, so which is this, we'll see that we see, which is X. So we'll see which is X. She won half of we'll see. So we'll see, so in this case it's Z. So which means X is equal to half of Z. Okay, that's a statement that you can write, which is the first equation. Let's move on. Sibusiso won 80 more than Lovio. Sibusiso, which is this Z. So Z is equal to 80 more. So 80 more, which means you are adding. So it's 80 plus what Lovio won, which is Y. So it's going to be 80 plus Y. It's a statement, that one. Okay. If 3 friends won 710 in total. Okay, 3, which means X plus Y plus Z. If we are to add this, X plus Y plus Z, we must obtain 710 rand. Calculate in total. So the question was, how much did each of the friends win respectively? So we need to know the value of X, the value of Y, and the value of Z. So that means this was just a normal substitution, guys. Here we are given that X is half of Z. Okay, whenever we see X, it's half of Z. So we can substitute in place of X. Okay, let me name my equation. Equation 2, equation 3. All right. Equation 1, we are given that X here is half of Z. So I can substitute equation 1 here in place of X. We can substitute X is half Z. So that means half of Z plus Y plus Y plus Z. Z here, we are told that Z is 80 plus Y. So Z, that's 80 plus Y. All right, that's 80 plus Y, like that. Okay, so I want us to have only Z or only Y in this case. So this is going to be 710. Okay, we said X is half of Z. Okay, so we can actually have in terms of Z. We want this in terms of Z. So I don't know which one was actually best for you to solve this typical equation. Okay, let's add and see what we are going to have. Half of Z plus Y, that is 2Y in this case. That's 2Y plus 80, which is equal to 710. But remember that in this case, we can find Y in terms of Z. Here, Y in terms of Z, because Z is 80 plus Y. That means Y in this case is going to be Z minus 80 if we are to transpose this side, so that we write it in terms of Z. Since here we've got Z, so this was going to be half of Z plus 2Y, which is 2 times Z minus 80 plus 80, which is there, which is 710. Okay, so that means we can calculate Z because this is now in terms of Z. So half of Z, this is half of Z plus 2 times Z, that is 2Z, 2 times minus 80, that's minus 160, plus 80, which is going to be 710. Okay, so let's collect like terms. Half Z plus 2Z, these are like terms, so you can add half and 2. So if we add half plus 2, what do we have? That's 1 over 2 plus 2. All right, so this is going to be 5 over 2 or 2,5. So we are going to have 2,5 Z. Okay, minus 160 plus 80, that's minus 80 there. Okay, anyway, let's use our calculator. Minus 160 plus 80, that's minus 80. So we're going to have minus 80, which is equal to 710. So 2,5 Z is equal to minus 80 to the other side of the equation. We're going to add, so it's going to be plus 80. So it's 710 plus 80, 710 plus 80, which is 790. Okay, so that's 790. Divide by 2,5 so that we can obtain Z. So if we divide by 2,5, Z is equal to what? 790 divide by 2,5. So this answer divide by 2,5 is going to be 316. All right, so that means we've got our Z as 316. So if we have got Z, that means we can find X because X is equal to half of Z. So X, that's half of Z. So that means X is equal to half times Z, which is 316. So X was going to be what? Let's divide. 316 divided by 2, that's half, which is 158. So it was going to be 158. Okay, to find Y, we said Y is equal to Z minus 80. So Y is equal to Z minus 80. So if Y is equal to Z minus 80, and we have got Z here, which is 316. So it's going to be 316 minus 80. So Y was going to be 316 minus 80, which is 236. So that's 36. All right. So that means in this case, if we are to calculate these amounts, remember we said X, Y, Z in terms of that. So that means in this case, we'll see the one which with X was going to be 158 Rand. Lovio, the one with Y was going to be 236 Rand. Then Sibusiso was going to be 316 Rand. So this is the amounts that they obtained. So even if we are to cross-check, if we are to add these, we must obtain 710. So 158 plus 336 plus 316, we must obtain 810. So this is 710, not 1. Okay, so let's cross-check. We've got the one that is 236. Okay, this is 236 here. That is why 236. Okay, so let's see 236 here, which is going to be 710. Okay, so that's it. So these were the values that they actually obtained each. 5 marks, these were the problems, guys, just for you to play around type of a question. Okay, given the following compound interest formula, make I to be the subject of the formula. So what can we do to make I to be the subject? Depends with the way that you actually need to work it out. So you've got P, which was equivalent to A over 1 plus I to the exponent of M. But everything to the exponent of any times M, and we want to make I to be the subject. Okay, so in this case, we can actually transpose, divide everything. So you can cross multiply first before we do anything. As cross multiply is going to be P into 1 plus, so it's going to be 1 plus I over M to the exponent of any M, which is equal to A. So you can divide by P both sides, by P both sides, so this can cancel. So 1 plus I over M to the exponent of any M is equal to A over P. Okay, so A over P is just a single fraction, this one, it's just a single fraction. Okay, so what can we do? We have got the exponent, and I is inside of the bracket affected by this exponent. So we can introduce ln, or we can introduce logarithms depending with which one was best for you. But in this case, I'm just going to introduce ln. Okay, so it depends with you, ln or log. So ln of 1 plus I over M. The moment you introduce ln, we know that this exponent is going to be dropped down. So it's going to be any M, which is equal to ln both sides, which is ln A over P. All right, so let's see, guys, what is going to happen in this case because we have introduced the ln in this case. I want us to see what is happening. We can divide, okay? Let's divide first. Divide by nm, divide by nm. I want you to see what was going to happen. This was going to cancel. So at the end, we are going to have the ln of 1 plus I over m, which is equal to ln A over P, everything over nm. Remember, this is a single fraction. So in order for you to remove ln, we introduce e. If it was log, for you to remove log, you raise 10 to the exponent. So if it is ln, you use e. So it depends with what was best for you to use ln or log. It's one and the same thing. So what I'm saying is that we want to remove this ln. So it is going to be 1 plus I over m, which is equal to e to the exponent of everything. So it's e ln of A over P over nm. Okay, so that's it from this part. It means this bracket is no longer necessary. It's just like this. So we can actually transpose and do whatever that we want to make I to be the subject. Avoiding working with negative, it is going to be I over m, which is e to the exponent of ln A over P, all right, over nm. So transposing this one here to the other side of the equation is going to be -1. So we are going to have it as -1. So to find I at the end, we've got I over m. So we are just going to multiply by m. So m times e to the exponent of ln A over P, like this, over nm -1. We have made I to be the subject of the formula. So it depends with the way or the step, but each and every step has to be valid. That is what is important if you are working with a change of subject. Either you're working with ln, you are working with log. I don't know which one was best for you, but actually these were the steps that were necessary for you to obtain the full marks. Okay, anyways, let's see the other part of the equation, which was 3.3. Not part, but this part is actually, yeah, you're supposed to know this part, guys. We are asked to solve for x and y simultaneously following two equations. These are two equations, but if we have to cross-check, one was a linear and the other one was a quadratic, which was something else to others to say, what type of equation is this, guys? You're supposed to now get used to these typical equations. So we've got the first equation, x plus y, which is equal to 3. The second equation, 2x squared plus 4xy minus y, which was equal to 15. So that was the second equation. So it depends with what you can make the subject of the formula. Is it x that you want to make the subject? Is it y that you want to make to be the subject? It depends with you. But as for me, making y the subject was easier because here I have got y, I've got, but take a look at x, there is x squared, which means whatever that you're going to substitute, you're supposed to square it, of which is going to take us time. All right, so anyways, working with equation 1, I'm going to make y to be the subject from equation 1. So y is equal to 3 minus x, which means we now have the third equation. All right, so I'm going to substitute equation 3 into equation 2. All right, so substituting equation 3 into 2, that means in place of y, we are going to substitute 3 minus x. So we've got 2x squared plus 4x times, in place of y, we substitute 3 minus x. Minus y here, we substitute 3 minus x, which is equal to 15. So that was it. As you can see, we have got equation in terms of x only. It's all about x. So you can expand brackets, collect like terms, and solve for x. So 2x squared, 4x, and 3, that is going to be 12x, 4x, and minus x, we've got minus 4x squared, minus 1 times 3, which is -3, minus and minus, which is a positive x. Then taking 15 to this side is going to be -15 is equal to 0. Okay, so that's a quadratic equation that we have. Let's collect like terms. 2x squared minus 4x squared, 2 minus 4, that's -2x squared. We move on to x, so we've got 12x plus x, which is 13x. We've got positive 13x. Then we've got terms, collect like terms like constants, -3 and -15, which was going to give us -18 is equal to 0. Okay, so from this equation, we can try to divide by negative. Avoid working with x squared with a negative, especially when solving equations. So we can divide by negative throughout, by negative throughout, by negative throughout, which is going to be positive 2x squared, negative 13x plus 18 is equal to 0. Okay, so that's the equation. You can choose to work it from quadratic formula. Factorization, I don't know what was best for you, because we are now left with a normal quadratic equation. So you choose which method is best for you to solve this typical equation. But as for me, I'm just going to apply my factorization. That is a first term and last term. If I multiply these two, I'm obtaining 36. 2 times 18, that's 36. Factors of 36, if we add them, we get negative 13, that is negative 9 and negative 4. Negative 9 times negative 4 is positive 36. Negative 9 plus negative 4, that's negative 13. So these were the factors that we are going to substitute into the middle term, which is in place of negative 13x, we substitute negative 9x and negative 4x. So it's going to be negative 4x, negative 9x plus 18 is equal to 0. So by that, remember by factorization, you group into two. The first two terms, 2x is common. We remain with x minus 2. Here, minus 9, so that it becomes a positive. So it's going to be x minus 2 is equal to 0. So remember that when the two brackets are the same, you just have to factor out the common bracket x minus 2. We remain with the 2x minus 9 is equal to 0. So definitely x was going to be 2. Or from the other part, it was going to be 2x is equal to 9. We divide by 2 both sides. So x was going to be 9 over 2 or 4 over 5. So these are the values of x, but we are supposed to find the values of y. Remember, you're solving not only for x, but we are also solving for x and y from this part. We are asked to solve for x and y simultaneously at the same time. So let's see what we are going to have for y. Since here we've made y to be the subject, remember we said y is equal to 3 minus x. So you can take that as an advantage. So like I said, guys, here we could have used quadratic formula. Use the method that you are best at on this one, on this equation here. On this equation, on this part. You can also use the quadratic formula to solve it. So use any method, but you're going to obtain same values like the one that I'm obtaining. Okay, anyways, we said y is equivalent to 3 minus x. So from the first one, y is going to be 3 minus x is 2. So if x is 2, y is going to be 1. Then we move on to the other one. Y is equal to 3 minus x, but our x is 9 over 2, so it's going to be 3 minus 9 over 2. So y is going to be, let's subtract 3 minus 9 over 2. That's 3 minus 9 over 2. That's minus 3 over 2. So y was going to be negative 3 over 2. So that is the values of y, the values of x. We've got all the marks. That was the typical equation. So on the value of y, you can substitute any. You can substitute on this quadratic, or you can just substitute on that y, which is already the subject. We are going to have the same answers from that one. Okay. Let's see the fourth question. That is question 4. We were given a fig below shows P, Q, R. So these are like the vertices that we are given. Then we are given that M is the midpoint here. This M that we see here was the midpoint. This is 2 minus 1, 5. Okay. Then we have got or the midpoint of QR. Any here is also a midpoint of PR. So, okay, that was what we had. So let's see the first question. Calculate or determine the coordinates of R. Okay, to find the coordinates of R here, remember that we are told that M is the midpoint. So if actually M is a midpoint, we can take advantage of that to say, let's just have it here. Okay, remember from the midpoint concept, for you to have the midpoint, you add the values of x, x1 plus x2 over 2. Then we've got y1 plus y2 over 2. So for us to find this M, that is what we actually did. We added the values of point P here, point Q and point R. This point Q here and the point R together. So we are just going to add. Okay, so we've got -1 plus r here, which is x, -1 plus x over 2. We move on to y, which is a 0 here. This is -1, 0. Take note, this is -1, 0. So it's going to be 0 plus y over 2. That is how you're supposed to obtain the midpoint. And we are given that that midpoint is m, and the point m is 2 minus 1,5. So we equate that one to 2 minus 1,5. So this is 2 minus 1,5. So by doing this, it can be an advantage because we can actually solve these two will be equal. The first one and the first one will be equal. So it can be an equation that you can use. -1 plus x over 2 is equal to 2. 0 plus y, that is y over 2, which is equal to minus 1,5. So here, -1 plus x is equal to cross multiply 2 times 2, that's 4. So x was going to be -1 to this side, that's a +1. So x was 5. Cross multiply on this one, y times 1, that's y. 2 times -1,5, which is -3. So we have the value of x. As you can see, the point r that we have, it's xy. So we have the value of x and we've got the value of y. So which means point r was going to be 5 minus 3. The value of x is 5, the value of y is -3. So that was 5 minus 3. So we can even write it down here, 5 minus 3. Okay. Let's see the other part, the coordinates of any, the midpoint of PR. So now we can calculate it. If this was wrong, it means it was going to be difficult for us to calculate the coordinates of n. Remember, n is the midpoint. So this is 4.2. All right, so you can just calculate it here. So n is the midpoint. So using the midpoint concept, n is going to be, remember we said x1 plus x2. So you're just going to add this term, it's 2 plus 5. So it's going to be 2 plus 5 over 2. You move on to y is 3, and this one is -3. So it's 3 plus -3 over 2. Okay, so n in this case was going to be 2 plus 5, which is 7 over 2. 3 plus -3, that's 0 over 2, which is a 0. So n was going to be 7 over 2, 0, or 3,5. Whatever way that you can write it, I think it's proper. Okay, so let's see the other part. The distance between P and Q in simplest set form. Take note, in set form. P, Q. Where is P? Remember distance. Okay, this is our P and this is our Q. Okay, so we need the distance PQ. That's 4.3. Okay, 4.3. Remember distance, we are going to use the values of x2 minus x1 squared plus y2 minus y1 squared. So we are referring to PQ. So in this case, P to Q, Q, x is -1. So it's going to be, this is x, this is y, this is x, this is y. So it's -1 minus 2. So it's going to be the square root of -1 minus 2 squared plus y, that's 0, and that one is 3. So it's 0 minus 3 squared. Okay, so we've got the equation, we've got the length of the line. We can just use your calculator direct, open a bracket. We've got -1, -2, close the bracket, then square it, plus 0 minus 3 in a bracket, that's 0 minus 3, then you can square it. All right, so in set form, your answer is going to be 3 square root of 2. So that is set form. So this is the length. Remember, length is measured in units. So you can just leave your answer like that in units. Okay, so that was 4.3. 4.4. 4.4, the equation of Mn. So on the equation of line Mn, and we are given the format y is equal to mx plus c. We have got m and n. Where do we have here? The point m, the point n. This is what we are working with. So there we can actually just take the points. Okay, m is 2 minus 1,5. That's our m. This is question 4.4. Is it 4.4 or 4.5? Okay, this is 4.4. Okay, so m, we say the point m, just going to take the coordinates. M is 2 minus 1,5. All right, so you've got 2 minus 1,5. N, we calculated n here. We got 7 over 2, 0. So it's 7 over 2, 0 here. Or you can write it as a fraction. It doesn't matter. 7/2. Okay. So remember, for you to have the equation of mn, we actually need the gradient first, which is m. So m is the gradient. That's y2 minus y1 over x2 minus x1. So you've got x1, y1, x2, y2, which is going to be y2. That's 0 minus y1. That's minus 1,5 over x2. That's 7/2. Minus x1, which is 2. So all these, do not worry, your calculator can simplify all these for you. Okay, so you've got 0 minus 1,5, everything over 7/2. So that's 7/2 minus 2. So the calculator can do everything. That's a 1. So the gradient in this case was a 1. So if we've got the gradient, therefore, remember the equation, we are told the format y is equal to mx plus c, where m is the gradient. So you can substitute 1, which is the gradient here. So y is equal to 1x, which is just x plus c. So to find c, we are just going to substitute any one of the points. I can substitute point, this point here, any point. So we are given that when x is 7/2, y is a 0. So y is a 0 if x is 7/2 plus c. So to find c, I'm going to transpose to this side. It's going to be minus 7/2. So c is minus 7/2. So therefore, our equation in the form of y is equal to mx plus c was going to be y is equal to x plus c. We said our c, that's minus 7/2. So that is the equation. Y is equal to x minus 7/2. So guys, make sure that you understand all these concepts. It was actually nothing on this one. Let's just cross-check the other part of the question. Let's see that. So 4.5, we now need to find, that was 4.5, the size of the obtuse angle, which is beta, the angle of inclination of line PR. Okay, so let's check our line PR. This is where we've got our line PR here. Okay, so we need the angle of inclination. So remember, for you to have this angle of inclination, you're supposed to calculate the gradient of PR or the gradient of PN, whatever that we have, but we need the gradient. Okay, so that's 4.5, 4.5. You can even do it here, 4.5. So P, it's a point. Remember the point P, you have the coordinates. P, that's 2, 3. So you've got 2, 3. And R in this case, that's 5 minus 3, 5 minus 3. So we are supposed to find the gradient of PR so that we can use it now to calculate the angle beta. Okay, so remember gradient, guys, does not change. That's x1, y1, x2, y2. So we're going to have y2 minus y1 over x2 minus x1. So in this case, y2, that's minus 3 minus y1, which is 3 over x2, that is 5 minus 2. So this is going to be, just use your calculator also not to be mistaken so that you can obtain everything. Minus 3 minus 3, so you've got minus 3 over 5 minus 2. So it's going to be negative 2. Okay, so this is the gradient of PR. So we know that we are supposed to calculate this obtuse, but what we are going to get is this acute angle here. This is the answer that we are going to have for the first time. So this is what we know. We know that the gradient, the angle of inclination is supposed to be arctan, the gradient. So it's arctan -2. So the -2 here, I want you to see what is going to happen here. Arctan, that's shift tan -2. All right. So the calculator, it gives you the acute angle, which is negative 63.43 degrees, something like that, negative 63.43 degrees. This angle that we see, it's the acute angle, which is like a reference angle. As we need this angle, which is the angle beta, this other angle. So we just calculated alpha, this one. This is our 63.43. So to find this beta here, we subtract from 180. Remember, angles on a straight line add up to 180 degrees. So therefore, our beta is going to be 180 degrees minus 63.43 degrees, of which we subtract, we can have something like 116.57 degrees. Okay, so that was the angle beta for that particular question, or question 4.5, which is the obtuse angle. All right, so let's see the other part, which is 4.6. The equation of the line passing through the point P, take note, it has to pass through the point P, and we are given the format y is equal to mx plus c, which is perpendicular to PR. Okay, take note, it's perpendicular to this line that we just calculated its gradient, and it passes through the point P. All right, so the first thing, let's see if we've got the point P. Okay, this is 4.5, 4.5, okay. Sorry for that. All right, sorry. Okay, let's just remove this. Okay, so this is 4.6, actually, not 4.5, 4.6. Okay, remember I told the equation has to pass through the point P. The point P is already there. Point P is 2, 3. And we are given that this line that we are talking about, it is perpendicular. Sorry, I did too much. It is perpendicular, which is perpendicular to PR. Okay, PR, we calculated the gradient of PR here. This is the gradient of PR, which is -2. Remember, for the lines to be perpendicular, the products of the given gradients should be -1. So PR is got -2 times the gradient that we need should give us -1. So if we divide by -2 both sides, it means the line has got a gradient of 1/2. So we have the gradient, which is m, and we are given the format y is equal to mx plus c. So we can just use this equation direct, because already the point P is there, the gradient is there, which is 1/2. So y is equal to 1/2x plus c. So to find c, you substitute the point P, which is xy. Y is 3, so in place of y, substitute 3. In place of x, you substitute 2. So it's half of 2 plus c. So 3 is equal to half of 2, that's 1 plus c. So transpose 1, 3 minus 1, that is 2. Okay, that is 2. So therefore, the equation is going to be y is equal to m, which is half of x, plus c, which is 2. So that was the equation in the form of y is equal to mx plus c. Take note, the format that you are given, whenever you are given a certain format to follow, make sure that you apply that format properly. Okay, so but that's what we had from this particular question 4.6 to mark the last question on question number 4, which is having a total of 18 marks. Then we've got the question on question 5, draw the graph of 100x squared plus 16y squared is equal to 400, showing the so that what type of a graph is that one, guys? We have got 100x squared plus 16y squared, which is equal to 400. So here we're talking about an ellipse. As we can see, these two are not the same. So we just have to find the x-intercepts and the y, just like that. We are done. X-intercepts. We know this one is when y is equal to 0. So if y is equal to 0, you're going to remain with 100. X squared is equal to 400. Divide by 100, definitely both sides. We are going to have x squared is equal to 4. Find x, square root both sides. So x square root of any number is plus or minus 2. Okay, we do the same for the y-intercept. For the y-intercepts, x is equal to 0 this time. So x is equal to 0. It means 16y squared is equal to 400. Divide by 16 both sides. Y was going to give us something like 400 divide by 16, which is 25. So 25, that's y squared. Square root both sides, y is equal to plus or minus 5. So as you can see, y passes through plus or minus 5, x passes through plus or minus 2. So the graph was supposed to be like this. X is plus or minus 2. So x is plus or minus 2. We can just say this is our 0 here. This is our 2. This is our minus 2. Y passes through plus or minus 5. So you can say plus, and this is -5. So that's an ellipse. Something of that nature. All right, so that was what you're going to have, the y-axis, the x-axis, and you can just name the equation. Remember the equation, it was 100x squared plus 16y squared, which is equal to 400. Okay, so that's what we had from this one. It was an ellipse, just finding the x-intercepts and y-intercepts. You can actually have your graph drawn properly. Okay, Fig 5 on 5.2, we have got Fig B that we are given, and from this Fig B, we are given that we have got the equation, which is y is equal to x squared minus 3x plus 2. Determine the coordinates of the turning point of D. So to determine the coordinates of the turning points, there are so many ways. We can use derivatives. We can use the concept of x being equal to minus b over 2a. Remember, if we have got an equation in the form y is equal to ax squared plus bx plus c, x is equivalent to minus b over 2a at the turning point. So you can have the value of x, which is minus b. In this case, we've got minus 3 over 2a. Our a is the coefficient of x squared, which is 2, which is 1. So minus, that's 3 over 2. So at the turning point, x is equal to 3 over 2. So the coordinates now, we substitute the value of y, the value of x, which is 1, which is going to be 3 over 2 squared. We substitute x, which is 3 over 2 plus 2. So you can obtain the value of y in this case. Okay, so let's see what are we going to have, because this is a point. Okay, so we've got 3 over 2 in bracket squared minus 3 into 3 over 2. So this is 3 into 3 over 2 plus 2. So we're going to obtain negative 1 over 4. So that was negative 1 over 4. So as you can see, we've got the value of x and also the value of y. So that's a turning point. So the point D, sorry, right, sorry. So therefore, the point D, x is 3 over 2. Y is negative 1 over 4. So that was it. Or you can use the derivative to calculate the value of x. There were so many ways for us to have the value of x. We can use derivative since we know that at the turning point, dy dx is supposed to be equal to 0. So that's the derivative here, dy dx. We are going to have 2x, remember, minus 3 is equal to 0. So 2x minus 3 is equal to 0. 2x is equal to 3, divide by 2, x is 3 over 2. So as you can see, we are obtaining the same value of x, which is 3 over 2. So that means we are going to obtain the same value of y again. Okay, so that was it. 5.3, we are now given determine dy dx using the rules of differentiation. The final answer should be with positive exponents and in set form where applicable. Okay, so the first thing first, y is equivalent to what? Square root of x is same as x to the exponent of half over 2 plus 1 over, take note the x is in the denominator, so it's same as 1 over 3 x to the exponent of minus 3 minus pi x. So this one I'm just rewriting so that we can be able to differentiate. Remember the derivative, we have to drop the exponent, then we subtract 1, we drop the exponent, we subtract 1, and so forth, and so forth, and so forth. Okay, so that's dy dx. If I'm to drop the exponent, it's going to be half of x. If I subtract 1, half minus 1, that's minus half over 2. We do the same, we drop the exponent, so it's going to be minus 3 times a third, which is minus 3. That's plus minus 3 over 3 x to the exponent. We subtract 1, that's minus 4. Here we've got a constant, so it's going to be minus pi. Okay, so let's simplify further. Dy dx is half over 2 from our calculator. That's something like 1 over 4 there. Half divide by 2, that's 1 over 4. So we've got 1 over 4 x to the exponent of minus half. 3 and 3, they cancel, so we've got minus x to the exponent of minus 4 minus pi. Okay, so that was it. But we are told our answer is supposed to be with positive exponents and in set form wherever it's applicable. So let's start by having positive exponents. How do we remove a negative exponent? It's 1 over. So it was going to be 1 over 4x to the exponent of half minus 1 over x to the exponent of 4 minus pi. Knowing that the x to the exponent of half is same as square root of. So therefore, dy dx was going to be 1 over 4, the square root of x minus 1 over x to the exponent of 4 minus pi. So that was our dy dx in this case. So these are the typical cases that you can actually have, or so you're supposed to be very, very careful in attempting these typical questions. Anyways, that was 5.35 marks for that. Move on to the other part of the question, which is 5.4. We are given a graph, a function, a sketch. Determine the coordinates of the turning point A. Take note, we've got two turning points. We've got this turning point and also another turning point. Same concept of turning points. Remember, the first derivative should be equal to 0, just like what we did from the previous question. So this was f of x equal to minus x cubed minus 2x squared. So we know that at any turning point, it must be equal to 0. So, okay, so that was it. All right, so in this case, we are supposed to find the first derivative with respect to x. Okay, drop the exponent here. That's negative 3. X, we subtract 1 is going to be 2. We drop the exponent here, that's negative 4x. We subtract 1 is going to be negative 4x. So we know that this must be equal to 0, the first derivative. So minus 3x squared minus 4x is equal to 0. So for x, we can factor out x is common. We remain with negative 3x, negative 4 is equal to 0. So it's either x is equal to 0 or the other part, which is negative 3x, negative 4 is equal to 0. So from there, negative 3x is equal to positive 4, divide by negative 3, both sides. So x was going to be negative 4 over 3. Okay, now we have to compare between the two. Which one is it? Here we can cross-check. Our a cannot be at 0. This is the 0, this one. So this is the one, the other one, which we have here, which is negative 4 over 3. So we're supposed to compare. So our a here is the one that is at negative 4 over 3. But remember, it's a turning point, which means we have to substitute the value of x to find the value of y in this case. So y is going to be equal to what? We have got our x being equal to 4 over 3. So that means y was going to be equal to negative x cubed, which is negative 4 over 3 to the exponent of 3, minus 2x squared, which is negative 4 over 3 squared. Okay, so that's how we can find the value of y by substituting into the equation that we are given. All right, so let's see. Just going to transpose this to the other part. Sorry for that. Okay. I wanted to have this calculator the other side. Sorry for that, guys. All right, but I think this way it can actually work. Okay, so we said we are going to have negative. There's a negative outside of the bracket. Okay, so there's a negative, then the bracket, there is negative 4 over 3. So it's going to be negative 4 over 3 to the exponent of 3, like that. Negative 2, open bracket, that's negative 4 over 3 again to the exponent of 2. Okay, we are going to have negative 32 over 27, negative 32 over 27. Okay, so that is the value of y to make a turning point, which is the point A. So A is a point, so you can write it in point form. A is the point X, which is negative 4 over 3, Y, which is negative 32 over 27. All right, so that is what we had from the question 5.4 to make the last part of question number 5, which is actually having 14 marks in total. So you see, guys, it's a lot of marks that we are actually having from these typical questions. So not wasting much time, we've got question 6, where we are supposed to apply the trig identities to prove the trig identities on question 6 point. So use trigonometric identities to prove that. We are told that we are supposed to use identities to prove. All right, so that was the question. We're just going to even write it aside. Here, I think it's going to be fine. Okay, so without wasting much time, we know that cosec is actually 1 over sine. So this was going to give us 1 over sine B times sec. We know that sec is 1 over cos. So it's going to be 1 over cos of B minus cot B. So minus cot, we know that cot is cos over sine. So it's cos B over sine B. So in this case, I choose to work with the left-hand side. Here we can multiply cos, 1 times 1 is going to be 1 over sine times cos, which is going to be sine B cos B, minus cos B over sine B. So this is what we're going to have at the end. We can actually apply our addition, our subtraction. Remember, addition and subtraction of fractions, we must have the LCD or the LCM, which is in this case sine B is repeating. So we've got sine B cos of B. So sine B cos B divided by sine B cos B, that's 1. And here we've got 1. So 1 times 1, that's 1, minus sine B cos B divided by sine B. As we can see, sine and sine here will cancel, you remain with cos. So it is going to be cos B times cos B. Already there is cos B there. So let's simplify. That's 1 minus cos B times cos B is just like x times x is x squared. So this one is going to be cos squared B over 1 over sine B cos B. So this is sine B cos of B. All right. On 1 minus cos squared B, we were supposed to come back to this identity. We know that cos squared B plus sine squared B is equal to 1. So if it is 1 minus cos squared, it just means we transpose this to the other side and we're left with sine squared B, which is 1 minus cos squared B. So in place of 1 minus cos squared B, we are going to substitute with sine squared B. So that was going to be sine squared B. From this part, we're going to have sine squared B over sine B cos of B. Okay, cos here we've got sine, so sine B into sine squared B, we are going to remain with sine B. We know that sine over cos is tan, so this was going to give us tan B, which is the same thing as what we had on the right-hand side. Remember, on the right-hand side, that was a tan. In this case here, we are asked to prove this is going to give us a tan. So that is what we're supposed to have. In this case, 6.1. Proving the trig identity. Okay, 6.2, calculate the values of x that will satisfy the equation. Take note, your interval is from 0 up to 360 degrees. Okay, so this is the equation. You can also rewrite this equation just like the previous part. Let's see what you're going to have in this case. That's 6.2. Okay, so 6.2, we are given 4 cos squared plus 4 sine squared minus 5. So in this type of equation, you are the one who's supposed to choose which one to work with. Are you going to work with sine? Are you going to work with cos? Okay, but there's something that was important here. Before that, we've got 4 and 4, which is common. So I can factor out that 4. We remain with cos squared plus sine squared. So this was going to give you cos squared x plus sine squared x, okay? Which is equivalent to 5 minus tan of x. Okay, from our identities, this gives us a 1. We know that this whole part here, guys, that's a 1. So if truly we are obtaining a 1, it means we've got 1 times 4, which is just a 4. So 4 is equal to 5 plus tan x. 5 minus tan x, sorry, that's 5 minus tan of x. So I can transpose, avoiding tan to be negative. So I can transpose tan to the left-hand side. That's tan x is equivalent to 5. Transpose 4 to the right-hand side is going to be minus 4. So it's 5 minus 4. So we've got tan of x, which is equal to 1. So that was it, guys. From our tan x, which is equal to 1, remember, you're supposed to find the reference angle, which you can find by finding arctan of 1. Okay, so what is arctan of 1 from our calculator? That's shift tan. We've got shift tan of 1, which is going to be 45 degrees. So x was 45 degrees, which is the reference angle. So which quadrant are we going to work with? Remember, we are taught from 0 to 360, we've got all students take calculus. Which quadrant do we have? Our tan being positive, because this is 1 being a positive. So we've got tan positive in the first quadrant and tan positive in the second quadrant. So in the third quadrant, so this is 45. This is 45 degrees. So in the first quadrant, remember, it remains as it is. So therefore, our x was going to be 45 degrees, or another x in the Third quadrant, we add 180. This is 45 plus a straight line of 180. So our x there was going to be equal to 180 degrees plus 45 degrees, okay, which is going to be 225 degrees, if I'm not mistaken. So I've got two values of x, which was going to be 45 degrees, and the other x, which was going to be 225 degrees. That was what the question was asking you to do. Okay, on 6.3, we're given a diagram with the values of A, B, A, D, D, C, all the values. Determine the following from this fig D that we have. What are we determining? Okay, let's see the question. The first part of the question was determine the following, the length of AC. So want the length of AC. Okay, that's A to C. In this case, we are to cross-check. We've got A to C. This side here, it corresponds with this angle. This angle corresponds with this side. So there we can use sine rule. Okay, so that's AC, the one that we want to calculate over the sine of the, and so forth. So remember your sine rule, guys. Okay, so this was 6.31. Okay, 6.31. So you know that A over sine of A is equal to B over sine of B. So it's the one that we want to calculate, which is in this case, is AC. So AC over sine B. So we're going to have AC over sine of B, which is the opposite angle to AC. AC, opposite angle is 70 degrees. So it's sine of 70 degrees, which is equal to B over the other corresponding pair. It's 4 and 60. So it's 4 over sine 60. So it was going to be 4 over sine of 60. Okay, so that's it. How can I remove this sine 70 here? I just have to multiply by sine 70 both sides, multiply by sine 70 both sides. So this can cancel. So therefore, your AC was going to be 4 times sine 70, which is 4 sine 70 degrees over sine 60 degrees. Okay, so from there, we can actually use our calculator to simplify that. We've got 4 sine of 70 in brackets divide by sine of 60 degrees. Okay, so that is it, which is 4.3402, something like that, which is 4.34. So we're going to have 4.34. Maintain the units which are given, the other dimensions, they are in centimeters. Yes, centimeters. So this was also going to be 4.34 centimeters. So that's AC. So AC is 4.34. Here we have got 4.34 here, 4.34 centimeters. Okay, so that was our AC. Let's check the other part of the question. Let's see the other part of the question, which is angle ADC. So we're going to calculate angle ADC on 6.32, AD2C. All right, so let's check where do we have this ADC from the diagram. Okay, from our diagram, this is ADC. That's the angle here. Okay, working with triangle ADC, we are only given sides 5, 6, and 4. This is, we are only given sides, so that means we can play around with the cos, because cosine can calculate an angle from sides only. What is the formula? We know that the cos of the angle that we are supposed to calculate, which is ADC, can be given by the formula B squared plus C squared minus A squared over 2BC, which is cos ADC is equal to B and C. These are the sides which are creating the angle D, which is we are referring to 5 and 6. So it was going to be 5 squared plus 6 squared minus A squared. That is the side opposite the angle that you are calculating, and that's 4.34. So it's going to be 4.34 squared over 2BC, 2B and C, we just multiply times 5 times 6. So that was our cos ADC. So cos ADC is going to give us what? From our calculator, we can just simplify 5 squared plus 6 squared minus 4.34 squared over, that's over 2 times 5 times 6. We're going to obtain the decimal 0.702 274. All right, so to find ADC as the angle, we know that this is going to be arc cos 0,70274, the one that we have there. So arc cos simply means shift cos. So shift cos of answer is going to be 45,35 degrees. So we've got 45,35 degrees. That's our ADC. Okay, so depending with what you had, but that was the easiest way to use cos. From this one, I think it was actually clear, very, very clear. Okay, anyways, let's see the other part of the question. Draw the graphs represented by the following trigonometric equations on the set of x's from 0 to 180. Okay, so from 0 to 180, you can just name, okay, this is, okay, let's just have it. That's our x here, that's our y. From 0 to 180, we can have 0 here, 90 degrees, 180 degrees. So we can actually use a table. We've got f of x, which is y is equal to half sine x. That's half sine x. We can just have a table for that. Okay, so here we can just have a smaller table. Okay, just a smaller table that you're going to use. This is x, this is y from 0 to 180. So we put 0, 90, 180. Okay, so starting with sine, half sine 9, this is, there's a half here, so it's half sine 90, half sine 0. So the first one is a 0 there. So we've got half sine 0, that's a 0 there. Half sine 0, guys, that's a 0. Okay, so we've got a 0 here. We move on, 0 sine 90, we just have to substitute this time. Here there's a 90, so we're going to obtain a half. Then we've got 0 sine 180, move on, that one is 180 here. All right, that's a 0. Okay, so which means this graph can actually go from 0 to half. Let's say it's a half here. So that's 0, 0, 90 versus 180 versus, so it was just supposed to be like this. From 0 to 180, it was just supposed to be like this. Okay, so this is the graph of y is equal to half sine x for f of x. Okay, the same thing on minus 2 cos x, we do the same, minus 2 cos 0 and the fourth and so forth and so forth. So you just use your calculator, negative 2 cos 0, which is going to be negative 2. So the first one was going to be negative 2. Negative 2 cos 90, we do the same here, that's a 90, which was going to give us a 0 here. We do the same on 180, says 180, which was going to give us positive 2. So this one is going to range from 2 up to negative 2. So let's say this is our 2, this is our negative 2. Okay, so the first point, that's 0 minus 2 here, 90 versus 0, and 180 versus 2. So it was supposed to be something like this. Okay, so let's see our sketch. But you are sketching actually the graph, of course. So let me just change the pen. Okay, so it's supposed to be something like this, to 90. Yes, something of that nature. Okay, so that was the graph of G, which is y is equal to negative 2 cos of x. So as you can see, these two are going to intersect at a certain point like that. So this question was just for you to sketch, show the coordinates of the turning points, the intercepts. So we've got our turning points here, 90 versus half, and the turning and the intersection and so forth, the intercepts with the x-axis, and we've got 6 marks for that to make 19, and a total of 100 from the whole question paper, which was written November 2022, Mathematics N3. So that's it, guys, for Meson African Motives, working on engineering, Mathematics N3, till we meet again.